It makes sense to start by taking a look at worker.js. Notice that when it receives a message from the main thread, it's going to get two things, the image data and the type of manipulation. E is the whole message from the main thread, and then the data is the user data that we're sending to the worker. So when I post a message to the web worker, I'll make sure that both of these are included. Back in the image app, or in this case my solution to it, notice that the loop is gone from manipulate image. That's because the loop now lives in worker.js. At the top of the script, I created the web worker from worker.js, and I just called it image worker. Whenever I need to use the web worker, I'll use the reference image worker. Whenever I need to post a message to the worker or receive a message from the worker, I'll refer to it as image worker. Back in the image app, or in my case, the solution to the image app, I'll start by creating a new web worker. The syntax is fairly simple, and then once I create it from worker.js, I can simply refer to it with this variable name. Down below in manipulate image, you'll notice that the whole loop is gone, and that's because it's being handled by the worker. When I'm ready for the worker to start doing its work, I'll simply post a message to it by calling post message on the variable for the worker that I created above. And remember, the worker is expecting image data and type, so I'm sending it an object with both. Here, the image data is what's being collected from the canvas after an image is uploaded. And the type here is coming from the button that was pressed. Here, let me show you. Each of the image manipulation buttons has an onClick handler, which posts a different string representing the type of manipulation that should happen. This type here gets passed to manipulate image. Next up is the onMessage handler attached to the worker. This function will be run once the worker sends something back. First off, I toggle the button abledness, so that's what grays out or grays back in, I guess, all the image manipulation buttons at the top of the page. And then I go ahead and grab the data and then return it to the context. Next up, there's the onMessage handler that's attached to the web worker. This function gets run once the web worker returns something back to the main thread. Once again, it passes a message back, which is called E here, and the actual image itself from the web worker is e.data. Assuming that there is an image, it gets put right on the canvas. As a good practice, I also included an onError handler on the web worker. It also calls a function, which in this case throws a web worker exception. All right, now let's see how all of this runs. I've opened the solution in the browser and I've loaded the Chrome image like before. I'll hit invert and watch. No jank, it doesn't freeze up, and then a few seconds later, the new one appears. Notice that there was no huge stutter, there was no jank appearing in the timer. That's a really good sign that that work, that image manipulation work, is happening off the main thread. Notice how the work pretty much stays under 60 frames per second the whole time. That's awesome. And also down here in the flame view, you can see the web core worker being spawned. This worker's work down here is all of the image manipulation that happened off the main thread. Very cool. But there is still that performance bug. Let me show you what it is. Remember, I said to start with the manipulate function before. This manipulate function can be found inside imagemanips.js. The whole of imagemanips.js is this manipulate function. And then using the string types that were passed to it, it decides what that function should be equal to. And then it runs the function using the parameters passed from the worker. Okay, that seems fairly reasonable, but why is this a bug? Notice how this is happening inside the for loop. That means for each and every pixel on the page, a new function object has to get created, and that's just a lot of overhead for the browser. So I refactored this loop. Outside of the loop, I figure out which function I need. I'll show you where this function came from in a second. And then I simply call that function inside the loop. This is much more performant because I'm not creating a new function every time I hit a new pixel. GetManipFunc is the replacement for manipulate from before in imagemanips.js. And instead of running one of the image manipulations on a pixel, it simply returns the function. This allows me to use the function over and over inside the for loop without creating a new one each time. So how does this perform? Let me show you. I've got the before and after fixing that performance bug. First off, notice how the new timeline looks way better than the old one, and the function itself, run by the web worker, finished in only 1 second, which compares very well to the 5 seconds when it was done poorly. All in all, I would be very happy seeing this timeline on any app.